Welcome to another Juniper sponsored webinar. Today, we'll be discussing Juniper Extension Toolkit, that open programmability for easy integration. My name is Robert Tang. I'm the Senior Product Marketing Manager focusing on network automation. Today, we're really thrilled to have Crystal join us today. So Crystal, would you mind kind of quickly introduce yourself?
Sure. Thanks, Robert. Hi, everyone. My name is Crystal. I am a product manager in Juniper. I work on different things on the Junos software like network virtualization and automation.
We'll start the webinar with the economic imperative by looking into market dynamic that service providers are facing today. We'll go over our vision of the automation journey to our self-driving network. We'll then take a deep dive into Juniper Extension Toolkit, as well to evaluate different use cases. Let's first take a look at the economic imperative. I think most of us know that network traffic continues to explode with billions of devices coming online every year. But let's first take a look at the graphic on the left side here. These are the latest numbers from IHS where they forecast service provider revenues. As you can see, it's pretty flat. Essentially, we're talking about 1% growth rate per year for the next number of years. And this is despite the fact that on strong underlying demand on network services. This trend is also pretty universal across globe, and where in Americas, EMEA, and APAC, service providers constantly struggle to grow their revenue. With all this going on, of course, network getting bigger, more complex, and in a sense, more difficult to operate. So for the chart on the right, we took the cost of a sale for a number of service providers in the US, and we divide that number by their CapEx. What we see is that for every dollar a service provider is spending to build a network, they're also spending a few more dollars to operate, to manage, and to maintain the increasingly complex network. More importantly, this trend is somewhat alarming in the sense that not only OpEx, CapEx is going up, but also the trend appears to be accelerating, at least for the few carriers we look at here in the United States. Now let's take a look from the operational standpoint. Broadly speaking, operation can be classified into three key factors: quality, cost, and speed. What I'm referring to speed here is not the bandwidth speed, but rather how fast can we get things done. So from the traditional operational standpoint, we can only satisfy two factors at the same time were a detriment of the other. So for example, we could increase the quality and the speed, but the cost will go up. Alternatively, if we want to decrease the cost, increase the speed, the quality will suffer. So it's the only time we can really get into the area in the middle of the chart that is improving speed, cost, and quality at the same time is when the industry is going through a transformation. And we're seeing this transformation today, which is automation. Here at Juniper, we have defined a grand vision of a self-driving network. There are a number of incremental steps or journey that we need to go through to achieve this ultimate vision. And here are the 4 steps. The first step is human-driven automation. It essentially automates the network provisioning and management by using standard-based network interface and data models. We refer to this phase as human-driven automation because it's the human who instructs the machine to perform selected tasks in a programmatic way. The next phase is event-driven automation. Once we have automated device provisioning, we want to collect information from this device to understand and to fine-tune the performance as required. So we build a close feedback loop between machine and the human, leveraging telemetry to collect key metrics, and we use automation to detect events based on the metric and take the action on this event. While this may seem like a fully automated cycle where there's no role for human, the human actually play an important role to build the rule-based logic or the playbook to drive this engine. This phase elevates the role of human as the brain that attach to the event to business logic and build rules that determine the action to be taken of this event. The next phase of the evolution is machine-driven automation, where machine is not just taking actions, but rather start learning and define the rules. And of course, a human still make the necessary decision when the machine cannot. Ultimately, the last stage will achieve a self-driving network that combines telemetry, workflow automation, DevOps, and machine learning to create an infrastructure that's responsive, adaptive, and ultimately predictive. Here's our Junos automation stack. At the bottom, we have our physical devices, both chassis as well as a line card. Above that is our Junos OS. Junos OS supports a number of automation frameworks, including Ansible, Salt, Ruby, Puppet, and Chef. It also supports open programmability with Python, Slack, as well as our own PyEasy. You can configure and operate device remotely using netconf. You can also develop and deploy customized applications using our JET APIs. Now, Crystal will provide an overview of our JET API.
The Juniper Extension Toolkit is a framework. So it makes Junos OS open and programmable in a simple and flexible fashion, providing developers with access to a set of high-speed APIs to change and retrieve states information for control and management plan services. So I can give a very simple example here. A JET application can add a new operational command, such as, say, show something states or status, to display some application-specific states or status, so which is not in the original Junos OS. The JET application can run on devices running Junos OS or run on another type of device in your system and connect over the network to a device running Junos OS. In other words, it can be run on-box or off-box, very flexible. Also, JET has the mechanism to be able to automatically detect errors in configurations, then programmability rollback. So you can do a commit check over netconf to make sure everything is syntactically correct and commit confirm if something went wrong, and then roll back to in the defined time automatically.
Thank you, Krista, for the overview. And looking back in Junos, we launched the SDK back in about 20 years ago. So how does JET compare to the your Junos SDK, for instance?
That's a good question. I was going to talk about the advantage of the JET over SDK. So first of all, it's about ease of use. Things like language agnostic. Basically, it supports for multiple languages like Python, C, C++, Java, Ruby, Go, and so on, whatever you can name it. Not only the language, the application development can be done on any OS, such as Linux, Windows, FreeBSD, and so on. And then it's a fairly simple framework API with extension documentation. You can find it, all over in Juniper.net. And second, JET can support for different kind of deployment models. Like I mentioned above, JET API are consistent across different deployment models, like app on box, app on VM, and app off box. Moreover, JET app developer can define their own API. So when our engineering team first designed this API, the JET API, the ultimate goal was to keep it as simple as possible and as easy as possible for a customer to use. Yeah.
Can you also elaborate what Juniper platform and Juno OS version that JET currently support?
Sure. So for the detailed information, you can always go to juniper.net. And the plan is to have the JET support across Juniper platforms. And I think the first JET support is from 16.2 R1. With the slides, I want to give you a view of what are included in JET API. So you can, see the list. It primarily includes routes, interfaces, firewalls, management, and notification. So have that in mind. You can have the idea what JET app you can build to achieve your goals. So I'll go down the list one by one to explain. So first of all, routes. So basically, it means you can add or delete routes directly in the RIB or routing table with your own logic based on your own business needs on the top of those normal dynamic routing protocols, like OSPF and so on. And the next is interfaces. Again, you can do add, delete, or modify interfaces. For the firewall, basically it means you can manipulate all those kind of ACLs, and that's a lot of case our customers is using. And then the management, basically it means whatever you can do via CLIs, such as those show commands, set commands, and so on, all of that you can do via the JET application. We see it's leveraged in many customers' use case as well, where they take decisions based on the value of the output of certain show commands and then make the next action item. And lastly, notification. It's similar to the management, which is the input source of the certain action. It basically closes the loop of the automation. For example, a router needs to listen to some event to take the next step action. The event can be an interface or the management, say the interface going down or going up. And the notification will feed that event change information to the system. And then the system will take the action based on the defined logic.
So Crystal, let's say compared to traditional CLIs, what are the advantages of JET?
Oh, that's a very good question. So for routes, interface, firewall, they via daemon API. And the advantage of doing something directly via API is simply faster. There's no time for commit check. API actually directly talks to daemon in the control plane, so on. And for the management and the notification, which has no API, but the option to access ephemeral database to achieve fast commit as well. The keyword here is really faster because it doesn't do commit check or things to slow it down. I can give you an example here. If you have a configuration, you go to CLI and commit. It takes 40 seconds. If you convert that CLI to JET application and push all those CLI via the management APIs, it will be way faster because it's going via that ephemeral database. And you have the option to go either to this ephemeral database or traditional static database. It's your option. Yeah, so that's the answer.
Great, thank you.
So this slide shows a very high-level overview of how JET API work internally. So it gives you a view of JET API framework. So this uses the netconf/young gRPC, MQTT to handle those, JET requests. So basically when a API request comes in, there is a broker in which it decides which daemon the request should be forwarding to. So these internal Junos process provides the processing, right? And, for instance, for any route-related API request, it will be consumed by the routing daemon, and if it's a firewall, it takes, forward. So given the fast is a key advantage here, the JET API is fairly useful for those SDN use cases which needs a high-frequency event changes for network control plane. So now I want to spend some time to talk specifically about this fast programmatic configuration here. The usual way we configure the router is like, on the right side of the picture, like a C1, C2 via CLI or netconf. It goes through the persistence database and need fairly big amount of time for commit validation. And, people who have experience for the huge amount of configuration size, it takes a long time. Now with the JET, we can see in the C3 and C4 case, there's no middle layer of validation. And it goes through this database called ephemeral instance. It basically skips the syntactical and semantic check. The confidence, because people may ask why no check, will it be a risk, right? Where the confidence is come from? The confidence is really coming from the nature of automation. No human error-prone operation involved. Now, let's see what benefits JET can bring to you, our customers. Some of the aspects I do mention earlier, but let's start from the language agnostic and goes clockwise. Okay, so first of all, language agnostic as well as OS agnostic. It means you can write your own JET application in any language and on any operating system. There won't be any learning curve there, and developers who choose whatever environment they feel comfortable with, right? And the next is internal API and external API are the same. So basically it means since the Juniper internal feature developments are all use these set of API, things like, inter-daemon interactions are well tested and validated. And next, we have consistent API across our platform, like, MX, PDX, etc. And one great advantage I want to mention here is compatibility across Junos release, which means if you write a JET app with Junos, say, 17.2 release, and then you decided to upgrade the system to, say, 18.1, and you don't have to rewrite or even modify the existing application, but just keep using the same. Basically, it leads to the next point, right? The API are decoupled from Junos release. It's release independent, and it's like a very, important things to remember. Lastly, there are fairly comprehensive documentation, I think I also mentioned earlier, on juniper.net to guide you through how to develop, deploy, and use applications using JET on the Junos OS. And I believe we have fairly good, the forum for developers to have different kind of discussion for the JET.
Thank you, Crystal. In turn, can you also share with some specific customer use cases?
Sure. I would like to share a couple. So this is the first use case I want to share. We actually built this for a customer, and they are a global satellite service provider. And what they do is they provide connectivities for vessels. Pretty cool, huh? In this particular instance, we were using some MX480s and ACX devices on the vessels themselves. But between those two, they have, the modems that talk through the satellites. And those different sites can actually move, so they can cross the particular beam within a satellite. And while they're in the middle of that beam, they're getting really good connectivity. But as they get to the edge of the beam, or there are weather changes, it can change the status of that beam and affect the service. So what we needed here to do was be able to dynamically detect that degradation of the service and make sure whatever vessel was out at the edge of that beam or had, the inclement weather would sustain a given level of quality of service. So that's the goal that we need to achieve. And we didn't want to do any hardware limitation, and you could have several classes of traffic to each vessel as well. So you have to have quality service for each one of those classes. Any particular status of one vessel should not affect any of the other vessels. So if you have the one that's out in the edge of that beam, is really affecting any others, that we should be able to control that through routing and the class of service. And it should not be only applicable to just the satellite modems. If we have something else that's connected to MX, we want to be able to detect that same type of degradation, even if it's hardwired or something like that. So they wanted to make sure that it wasn't specific just to those modems. So this is a basic construction of what it looks like. At the top, you have the MX, and there is a server connect to them. We could run the JET application on the server or on the devices themselves. And then there is site modems that are connected to these MX, and that's where we are getting to information from into the application to decide how to change that class of service on the MXs. Those site modems communication across the satellite to those moving vessels, and they have modems on their side as well. And on the back side, they had ACX, which provides routing and connectivity for whatever is on the vessel. So in a summary, I just want to give you a view of what exactly this JET app doing, right? So this JET app pulls modem data as predefined intervals, and then dynamically computing the QoS parameters value based on the ship-specific properties. It modifies the policies on the MX ingress interface for each respective ship to ensure proper QoS. For the second use case, I want to share this JET for the third-party software integration. It's a very interesting use case. So the major motivation here is to solve the problem of IPv4 address exhaustion for a large multinational service provider based in Europe. So Lightweight 4/6 is one of the models that provides IPv4 access over the IPv6 network. We call it lightweight because it's an optimized version compared to the DS Lite, where it moves the network address and port translation function to the home gateway, the B4, but only performs encapsulation of IPv4 packets or decapsulation of IPv6 packets. Now, in this use case, subscribers are used the private IPv4 addresses in their home network, And each home gateway perform the NAPT mapped to shared public IPv4 address and a unique port number range for each home. Then those home gateways encapsulate the packets in the IPv4 in IPv6 fashion and ready to ship over an IPv6 cloud and vice versa. Now, for those IPv4 hosts to access the IPv4 internal across the IPv6 cloud, the packets needs to decapsulated when uploading or encapsulated when downloading. And that's where the VMX with Library 4.6 VNF comes to play. So the customer can simply run a VMX with such third-party VNF and achieve the goal with uncompromising throughput and a great scale. Here, the JETs plays a very, very important role to make it happen. So basically, we delivered a JET app to provide seamlessly management plan for the VNF with not only Junos CLI, but also YAN netconf support. So for more information, you can search for Juniper Snap Library 4.6 as a keyword in Google. And we have a white paper, very, very detailed white paper, as well as the application detail release notes for it. We actually also produced a webinar on this topic.
Thank you, Crystal. This has been very informative, and particularly in the deep dive on the JET API. Thank you very much.
No problem.
For years, we have talked about making things cheaper. Now we have to talk about making things faster. Instead of worrying about digital transformation, we need to be worried about digital disruption. It's very plausible that a well-funded unicorn with a billion-dollar valuation can transform an entire industry overnight with the latest application on the phone. The only way to combat this kind of challenge is to be fast. Automation, facilitated by JET API and other Juniper automation capabilities, is all about driving speed. Automation increases agility, contain costs by eliminating manual process and human error. With open and programmability, it enables service providers and enterprise to rapidly ideate new service, create new IP, build better customer experience, and ultimately sustain profitability. I hope you found this webinar informative. To learn more about our automation capability as well as different use cases, please visit juniper.net. Thank you for your time today. See you